In this problem, we can see the benefit of thinking of more than one way to do a problem. In number one, we're trying to form a fundraising committee of 5 members, and we want to not only elect or choose the members of the committee, but we also want to designate one person as the chair. And so an obvious two-step algorithm that one could do for this would be to think about how the laws of the club might work, where first the committee is chosen, and then the committee sort of selects or designates which person is the chair. So if you think of it that way, then there are, what are there, 41 people here? There are 41 choose 5 ways to choose the committee. And then once you have your committee, you designate one person of those 5 to choose the chair of the committee. And so the total number of ways to designate a committee and also a chair would be the product of 41 choose 5 times 5 choose 1. Now, an alternate way of doing that would be to first have the club elect the committee chair first as a special person. So choose a committee chair from all members, and then choose the other 4 people. To serve on the committee with that chair. And so in that case, we would say the total is, how many people were there again? 41. So there's 41 choose 1 ways to pick the person from the whole group who's going to chair this committee, and then only 40 people remain, and we're going to choose 4 more of those to sit on the committee. So it may not be completely obvious that these two things are the same, but if you write out what they're equal to, you'll see it. I'll do that here. And so here are the two expressions for these things. So here I can see I have 41 times 40, 39, 38, 37, and there's this times 5. That would cancel with the 5 here, leave me with 4 factorial down here, the denominator. And here I also have 41, 40, 39, 38, 37, the numerator, divided by 4 factorial. So numerically, these are the same. So it's not, it's definitely right that either one of these counts the same number. So the second question, how many of these committees is the committee chair a math major? Only one of these algorithms is easy to modify. The second one is easy to modify so that we have what we want, because the restriction here is on the committee chair having a specific status. So that's the most restricted part of the problem. And in this algorithm, I'm doing that step first. So if you insist that the math major, so I'm doing number 2, now problem number 2, if you insist that step 1 is a math major, then the number of ways to do step 1 is, oops, not 12, 11, choose 1, instead of 41, choose 1, because it has to be a math major. And then the second step is the same as it was before. The other 4 people can be whatever. And so the total number of ways of doing this second algorithm, where we guarantee that we have a math major as chair, would be this. So that answers question number 2, and that is a much more difficult, it's much more difficult to try to modify this algorithm to answer number 2. And the reason is because the thing that's the restricted condition here is about being the committee chair, and here you're doing it second. So the rule of thumb we use is whenever there's a restriction, and we're doing with these multi-step algorithms, we should try to account for the restriction as early as possible in our algorithm. And that's what this second approach is doing.